welcome to the talk. So a little bit background about this talk. So I was working in an investment bank, which shall not be named, and about 6-7 years ago, I was actually giving a class on Java performance tuning to the internal developer, and this is the concentrate of that class of whole day into 45 minutes. So we won't have enough time. I will rush through a lot of things, but what I try to do is give you a taste of what's being involved in Java performance tuning, and hopefully you can go off and find all the other details that I'm going to miss out in this talk. Okay, so it's really, really basic introduction on what's going on, and there will be some missing out. You might have heard some of this before, which I hope some of you did. But what I find is that when I deliver this class to the internal developers, most of people isn't aware of a lot of this. So hopefully you'll pick something up that's useful. All right. So in the next half an hour, 45 minutes, I will just go through the reason why we want to measure application performance. How do we actually measure this? What tools do we use? There are many, many tools. There's some very expensive ones. There's some free ones that's really great. I'm going to tell you a little bit about those. I think a lot of this, sort of like the stuff that you go on the Google search and they say, oh, this tool is great, but they don't tell you some of the pitfalls or potential issue that gives you the wrong result. So I'm going to tell you some of those pitfalls. And finally, if we have time, I have a live demo to show you. So hopefully, if demo God is being good today, then we will have a good demo. All right. I haven't talked a little bit about my background. So I'm actually coming from a JVM developer. My first graduate job was a JVM developer at IBM, and then I moved into financial industry. I work in an investment bank, being the Java engineer, so specialist on Java JVMs. So now I'm working in a crypto exchange as a senior Java developer. So that's a lot of the stuff that I've seen during my work that I've concentrated on this talk. Okay. All right. So let's get into the nitty-gritty details. So when we talk about Java performance tuning, sort of like, why do we want to do that? So if you're a developer, your boss tends to come and ask you, say, hey, sort of like, we have this new fancy web application. Does it actually scale if we have 10,000 or 100,000 more users into the system? And also on top of that is that, so if we now have this 100,000 users, how long does it take? Does it actually take longer to service each request because your database is take longer or your processing is take longer? So can we actually improve on that? And now that our business is scaling, how can we actually scale our service by putting more servers, or whether there's opportunity to save money? So these are very, very valid concern from your boss, right? And the performance tuning tools is going to help you to address those questions. So that's why we want to do these measurements. And so especially from my field, where I work in the financial computing, time is money. So just to give you a bit more sort of like, examples on how that's going to work. So when we're talking about electronic trading, whether it's stock or currency or even cryptocurrency, time is money, or the speed is money. The faster that you can make a trade, so if somebody's trying to sell lots of currency and buy the crypto, the faster you can make and respond to the market, the more money you can make. So milliseconds can be a difference between winning and losing a lot of money. Million is just a big number, but it actually does that. when I was working in the bank, one of the things, so we're talking about like 10, 15 years ago, we actually start to put, originally some of the servers between Exchange and the bank used to be quite far apart, and they link together by a piece of fiber optics, which is already very fast. But as the trading time sort of like compressed, we literally have to start putting server next to the exchange so that the fiber is literally like 1 meter instead of like 1 kilometer or 2 buildings. So that's how much time is actually making a difference in terms of the latency. It's making a difference in terms of the trading. Okay, so I'll give you a big picture of why we're measuring, right? So now let's talk about some of the concept of what are we trying to measure, okay? So a lot of the time, your boss will come and ask you, hey, how fast is our system, okay? But what do you mean by fast, right? There's a lot of meaning for fast. Fast it means that a user can see the response coming out quickly, or whether sort of like, you can process the data very quickly. So first thing we need to do is to understand what we're trying to measure first, okay? So I'm going to give you two concepts for you. It's the throughput and latency, okay? So the easiest way to think of it is, let's say your process is basically pumping water from top of the building to your flat or your house, okay? You can obviously have a very big pipe, okay? And then you can push lots of water through that big pipe, right? So that's what we call the bandwidth, okay? And the throughput is basically how much water you can deliver. So I've got big pipe, so I can deliver like 10 liters per second, right? But what happens is that if that pipe is very long from one end to the other, so your flat is like 34 or 50th floor, then that pipe is going to be very long, right? So the water that have to come from the bottom of the building to your flat at 50th floor is going to take time, right? That's what we call the latency, okay? So if you translate that into your website, when your website, somebody make a request, if your process is taking a long time, the latency is going to be very long. So it may take like 1 or 2 seconds to come back. But then the throughput might not be too long, because for throughput, you could potentially still have same amount of water coming out the other end because the pipe is big. But because the pipe is very long, your perceived latency is going to be very, very slow. So that's one of the important things you try and do, because when we're talking to a lot of developers, they will think, oh, sort of like, my system can process like 100,000 requests per second together, which is great. But the problem is that the latency, which is how long it takes from bottom of the pipe to top of the pipe, or the request, when you send the HTTP request to the server and it comes back, it might take a long time because of the potentially processing inside there is taking a long time. So we need to be clear about this kind of concept to make sure that we are measuring the right thing, okay? Because the way to measure it is different, right? So that's throughput and latency, okay? So a lot of the time we measure throughput and latency, but there's also other characteristics that we want to think about, right? So for example, want to think about the uptime. So these are also, your boss will ask you sort of like, how many downtime do we have for our system, right? So that's availability. And nowadays, most of your applications run on the cloud, and cloud charges you by sort of like CPU time, by memory, by disk space, right? So the effective use of resources is also an important thing, because obviously that's money, right? If you need to use more CPU or more memory, that means that your cloud bill is going to be a lot higher, right? So we also concerned about those effective use of resources. And obviously scaling, how it scales, can we chuck more server? That means horizontal scaling. Or do we need a bigger server, sort of like more CPU in order to get it faster? So that's what we call vertical scaling. You think of it, vertical scaling, you make a bigger server. You buy a sort of like jump from one cloud, sort of like sort of like, I think what they call is sort of like the E5 and E6 and etc. You get a bigger server and a bigger CPU and more memory, right? That's vertical scaling, or whether you can chuck more instances to actually scale it horizontally. That's what we call horizontal scaling. Okay. So all this measurement needs to be, the important thing is that all this measurement needs to be integral to your development process. Okay, so don't start doing this after your system is all running and working and things like that, because a lot of the times when you do this, there are potentially improvement that you can make at the design stage that makes it horizontal scale or better, or be more effective on the system. So don't leave your performance engineering to the last minute. Okay, bring it into every single stage in your design to think about the performance, or how to measure it, and how to collect that characteristic. Okay. Right. So now we talk about what we are trying to measure and what we're trying to collect, what information we're trying to do. The next thing is to say, okay, so how are we going to get some of these numbers that we care about? Okay. So the very important part of the tools that you have to develop. So like you write unit tests for your application, you write integration tests for your application, you also need to write a piece of tests called benchmark for your application. So how do you write a good benchmark? And by the way, if you don't know what benchmark is, it's basically a piece of program like unit tests, but it actually measures how long it takes for certain operations, or how long it takes to do certain things of your throughput, measure throughput of the application, how many users that you can scale. Okay, so that's what the benchmark is. So for example, if you're running a website, you have a user creating orders. So that benchmark will simulate how many orders that you can put through the system, and then measure how long it takes and how many users you can process, right? So that's a piece of benchmark, a benchmark program. So it's similar to a unit test, but specifically for measuring performance of a system, to help you to measure performance of a system, okay? So how do we write a good benchmark, okay? So it's important that your benchmark simulate the workload and as close to production as possible. So for example, in my field of work, so when you run a cryptocurrency exchange, one of the things they do is record the trade over a day. So let's say you also pick a couple of days, so Monday, Wednesday, and Friday. Okay, you collect all those trades that you've done, you put it into a separate system, and you replay the messages back into those systems in the standard production condition. So what that allows you to do is to make sure that whatever you're measuring is going to be very similar to what you see in production. I'm going to show you an example where if you don't do it correctly, it will give you a wrong result. Okay, so bear that in mind. I'll show you how that works. Again, similar to all the other unit tests and all the other tests that you write, it needs to be repeatable and verifiable against the system. So when you run it again, it won't give you all those funny results. That's not as easy as you think because of a lot of the effects, which I'm going to talk about later on in the talk. So the third thing and the fourth thing is kind of related in terms of how to write a good benchmark. So make sure that you know what measurement you're going to measure. So I'll talk about throughput, latency. So if that's what your systems care about, then you need to make sure that you measure it correctly and they're meaningful. So I've got a couple examples. So for example, you might collect average latency, as in let's say you're running a website, taking REST requests and do some processing, doing certain stuff, and then return the result to user, right? You can measure the average latency quite easily. So you set up a HTTP request sample, and you send the request to your system, and then you send like 100,000 requests, and then you divide the time that it takes for that 100,000 requests, and then sort of like, you can collect the average latency. But that measurement doesn't actually give you any useful information. Why? Well, if you think about it, let's say if your system is sort of like have requests one after the other, okay? Then that means that it's going to be very, very fast, because your system, however you scale your database, only process one order, okay? And then you get the average latency, great, 5 milliseconds, that's good. However, in real life, what you have is it's like DDoS, right? Denial of service, right? People tends to come in, like 100 users or 1,000 users comes in, make the request together, and then sort of like they will see it slowly, because obviously you have contention with your database or your disk or your whatever concurrency tools that you use with the memory, right? So in real life, when you actually do that, so if you don't do that measurement correctly by actually sending multiple requests to your system and simulate that, what you see, the average latency is completely useless. It doesn't represent what you have in production. What you instead need to measure is how it's the 90, 95, and 99 percentile, right? So you got 100 users, you set up multiple machines, sending requests to the system all together, and you measure the difference of like how long it takes for each order. So some of them may take 5 milliseconds, but you will definitely see some of them, because of contention, whatever in your system, will take 50 milliseconds and 100 milliseconds, because those orders were stuck in certain systems, certain places. And that is more interesting to diagnose than the average latency, okay? So that's basics of benchmarking. So obviously, I don't have huge amount of time today. As I said, we do this course over six hours for a day. So if you want to know more about this, I highly recommend if you go to YouTube and search for Joe Tanay. So he's the CTO of Azure System, and he does a very good talks over the years about how people making mistakes, measuring the system performance and things like that. So I highly recommend you to go and have a look at the talk if you want to know a bit more about how to write a good benchmark. Okay? Great, we're doing good in time. All right, so let me show you an example on how you actually measure, if you measure it wrongly or doing the wrong thing, it will give you a completely useless result, okay? So I have a really simple example people would write, and especially people coming from other programming language background would write. So let's say my system, I'm interested in the performance of multiplication. So I'm interested in numbers. So I don't know what perhaps you're doing AI or whatever. You're doing some inferencing, and you need to multiply lots of numbers together, right? So your boss will come and ask you, hey, what's the Java multiplication performance is like? So you write a program like what I did, okay? So, okay. Oh, hi, yeah. So I'll write a program like this, okay? So what I do is I take two random numbers, I just add them together, put it into V, and then I just take the time before I start, right? Okay, simple. So I've already done some before. Let's say I multiple 1,000 long numbers together. So by the way, when I did this test, when I wrote this presentation, so like, it actually needs to milliseconds. Now it's actually nano on my PC, so you can see how fast things has moved. So it's now 9,000 nanos to multiply 1,000 numbers together. Okay, so and I've done that for 10,000, and you can see that this is growing by 10 times, right? So if I multiple 10 times more long number, this is increasing 10 times in the times it takes, right? So far, so good. Now, if I have 10,000 or 100,000, so that's 10,000, that's 100,000 numbers, that's taken sort of like 88 times more is about, right? So that's 10,000 to 81,000, that's 8 times more, right? So that starts to be a bit funny, right? You would expect that if I multiply 100,000 numbers more in sort of 10 times, this should be 10 times, right? But it is not, is it, right? So let's try some more. So if another 10 times more numbers, that's not quite 10 times, right? That's only about 2.5 times of numbers. So it's 137,000. It's not 10 times, right? This is about 10 times. This is 8 times. This is, 2.5 times. What's going on here? So what do you think if I multiply another 100,000 more? So 10 times more than that? What do you think this time would be? Anybody would guess? What do you expect? Don't know, right? Let's try it. Okay, so I'll get my IntelliJ out, and I've got this. So let's try this. Ooh, sorry. So it's 100,000. Okay, so if I try this, how long it takes? So it's 130. So it's 1327052. Let's try another 10,000. So I put another 0 in there. Let's see what happens. It's only taking about another 30,000. It's not 10 times more, right? Why is that? What's going on? Does anybody guess what's going on? Right, that's right. What happened is that, remember, Java has something called JIT compiler. So it doesn't initially use interpreter, and then it compile your code. As it execute more, it compile your code into a better code in assembler using the JIT compiler. So what we end up with is that if we go back to the numbers, so initially, it will actually does the interpreter loop. So it will actually do the interpretation. So that's exactly what you expect if you just execute straight code. By this time, the JIT compiler will kick in. So it actually got a little bit faster. And after you have 100,000, one trick is, did you notice we multiply two numbers together, so put into V. Do we ever use the V again? No, we don't. So the JIT compiler will do something very clever, is that, oh, I never use V again, so I'm not bothered with calculating it at all. So by this time, it will work out, after it multiple 100,000 times, it will work out, oh, I never use V, so I'm not bothered calculating it. So this is why, however much you throw at it, it will become constant time, okay? So this is an example of why you should be very careful when you do measuring performance on Java. It's because of the JIT compiler. So how do you prevent this kind of thing? Luckily, we have somebody who is expert, sort of like, in this kind of measurement, and they've already worked out all the problems for you. So if your boss ever asks you to measure all this performance, make sure you write your tools with JMH, which is called, it's a very great framework. If you write simple unit tests for performance, when you do microbenchmark, so they already, for that issue, they already have a tools to generate a black hole. So in fact, what you do is you write your test in JMH, it will actually have a framework for you to throw the V that sort we forgot, and throw it in the black hole, make sure the JIT compiler doesn't optimize out that number. So use JMH. And another thing to remember, because we've got JIT compiler, when you make a request for your system, make sure that when you measure performance, you warm up your JVM. What it means is that don't start measurement when you start the benchmark. Make sure you let it warm up for 100,000 or 10,000 requests, and then start measurement. Then you will get a good kind of representation of what you see in production. And there's all sorts of other tricks and tips and tricks to do that. I don't have time to talk about all of that, but I think I want you to remember this when you try to run benchmark and things like that. And again, you can go on YouTube, Jutane, and all the other developers have a lot of these issues kind of show you on those YouTubes, and I highly recommend you to take a look at those presentation. Okay, I'm going to rush through this because I'm going over a little bit. So sort of like, excuse me if I didn't explain it fully, but I'll try to go through a lot of this. Okay. So now you have a benchmark. You have a tool to actually exercise your code. How do you actually work out the performance issue? So the next thing is you need to make sure your application is observable, being able to measure the performance. So now, let's say now you've got a benchmark, you throw 100,000 requests to your system, and you see that certain parts is very slow. It's taking a long time. So where do you find that slow part of your system, right? And so we have a lot of tools. There's some that's sort of like you have to pay for, and there's some that's free. So I'm going to show you the free ones, but there are ones that is sort of paid, and that's a similar kind of job as well. So I'm going to talk about the Java file recorder and the async profiler, and I'll show you how to use Java file recorder to find a kind of a demo sort of like issues in the application. Okay. Right. So as I said, there's lots of tools that have do profiling, but they all falls into two different types of profiling. Most of them fall into these two categories. And it's important for you to understand what these categories are, and I'll explain why. So the first type of profiler that you use quite often is called sampling profiler. So what it does is every 10 milliseconds or something like that, it takes a stack trace or whatever's the state of the system, and then you create a kind of a snapshot of what's going on, and then after you collect those information, it do processing and generate all the nice diagrams for you, okay? So this is very low overhead, collecting stack trace. Now you can do it very quickly, easily, but it's also inaccurate. So what it means is that because you're only sampling at certain interval, whatever happened in between those sampling interval, you have no idea, okay? And so potentially, if you have event that's actually quite significant, but it's shorter than the sampling frequency, then you will not see it, okay? So that's why it's inaccurate. And so these are ideal for when you have no idea and you want a big picture of what's going on. So things like Java profiler, async profiler, those are very good at that type of stuff to investigate what's going on initially. Okay. So the second type of profiler is called instrumentation profiler. What it does is it actually insert code. So I don't know whether people still remember AOP and things like that, aspect-oriented programming. You kind of insert a piece of code in the beginning of your method, and then you time it, and then when you exit the method, you take another measurement of time. So then you work out how long it takes for that method, right? So obviously, you insert code into your logic, so that means that you modify what is executed. So it also takes time to do those calculations. So there's high overhead, but it's more accurate because basically you're actually sampling every single execution, right? So that's very useful when you do in-depth investigation on specific issue. Okay, so some examples like JProfiler. That's something you have to pay for it. And HPOF also have a similar kind of mode that's come with the JDK. So if you go on Spring AOP, there's also profiling support like that in your system. Distributed tracing is also another good example of that, of collecting that kind of profile information. Okay, so why do I talk about this kind of different types of profiler? My boss used to be a physicist, and he's always quoting this as a very good example of why you have to care about it. So I don't know how many of you are study physics in high school and things like that, but this is a good way of remembering why the profiler makes a difference, okay? This is called Heisenberg uncertainty principle. So what happened is that if you think about how when you actually see an electron or proton running around, right? How do you measure the speed? Well, you measure speed by firing another electron or something smaller at it and see how it's bounced off, right? So if you have studied physics, you will know that if you bounce something off for a moving object, you will actually send it off in a different direction because you push some kinetic energy, right? So what it means is, whenever you measure, you can never tell exactly where the proton is if you try to measure something. If you try to measure an electron or things like that, when you measure it, you already change the state of that or the system. So how does that apply to profiling? Remember, I talked about you are using CPU time to collect stacks, or using CPU time to insert extra piece of code to collect this data, right? So you are modifying the timing of your system, right? You are modifying, you're making it do extra work. That means that the profile will be slightly different from what you expected. You will have a situation that perhaps your application is multi-threading, and there's a certain bugs that's timing dependent, right? So if you delay for another 5 milliseconds, then it wouldn't trigger that bug, or it wouldn't trigger that bottleneck. So if you start measuring, you potentially change that timing such that you will never see that issue. So when you are measuring, bear in mind to that, because I have seen so many cases that when they just run it, oh, I see this is really slow, but then attach a debugger or attach a profiler and the issue gone away. That's the reason. And it's really important to bear that in mind when you use these tools. Don't sort of like, if you fall asleep for most of the talk, remember this. This is the important thing to remember. Okay, so I've got 15 minutes. I think we're doing good. Let's take a look at some of the tools. And for this Java flight recorder, let me just do the demo, and then I'll go through the slide, okay? So I've got this piece of code. Have everybody heard of the 100 million lines coding competition? 100 billion lines? So earlier this year, there's a bunch of Java developer. They want to see how great Java is in processing data. So they come up with a competition to say, okay, so we've got 1 billion lines of weather data for a city, and then you've got the weather. And so basically, you're trying to write the quickest way of actually calculating mean, max, and average for that for all the city pairs in that 1 billion lines. Okay, so I'm not actually trying to do that challenge. Well, I did that challenge, but in not the most sort of like optimized way, but in a way that you would have written. Because if you really want to get the fastest number, they use all sorts of crazy trick, which you wouldn't do in your production application. Okay, so so that 1 billion line is basically a text file. So I just load up the text file. It's in a format that you have a semicolon in between the numbers, and then you kind of calculate it. Oh, in fact, I forgot to reset the data. So let's say, so let's try this example. So if you have to parse a number of line, right, you would probably written something like this. You would probably written something like this. Okay. Okay, so you would use a regular expression to split your line, okay, with a semicolon, and then you can't pass data, right? So that's what most of us would written, okay? Now, let's say, so let's run this and see what happened. And I'll use the Java flight recorder tools to actually collect this information. So if I run this, okay. Now, and then I'll go to this tool called Java Mission Control. You will able to see our application is now being run. So let's collect what we call the flight recorder. Remember, I talked about collecting the information, right? It's a sampling profiler. So it takes a sample every 10 milliseconds and collect and see what happens, right? So you can see it's recording. So I'll record it for 30 seconds, and let's see. So you can see this is running in the background. Okay. So what the Java Flight Recorder does, and the Java Machine Control, is basically it builds into JVM. It collects stack traces and JIT compiler generated information together, and it presents it in a way to show you what's going on inside the JVM. Okay. So it will collect, understand what's going on with different threads, and also see what's being allocated in your memory. Okay. So remember, we're passing lots of lines. So we expect that lots of strings is being created because of you split them up and things like that, right? Now, the interesting thing from this profile is, let's look at the method profiling. So what this shows you is, remember, it collects stack traces every 10 milliseconds, and then it counts how many times. So as I said, remember, because we are sampling a certain interval, this number is not exactly, so like it didn't call that method 434 times. It's just a kind of scale representation of that. So bear that in mind. So don't take that number literally. It gives you an idea, basically. So you can see that it's actually using the regular expression fine, that's pretty much where the application, when you pass number, is going to span in there. So can we actually do better? And by the way, take a look, and it took 1 minute 7 seconds. Okay, so I already know this, right? But if you have no idea why it's slow, then obviously you would investigate on see how to improve the performance of that regular expression, right? In fact, there is a way of actually doing it. So let's try this code. And the change is, instead of pre-compiling the regular expression, I just use it directly. Okay, so that's different. So let's try if we put that into the code and see what happens. Hey, hang on. Okay, let's run it and see what happens. So it took about 1 minute 7 seconds before. So let's see how long it takes for this one. It takes more than about a couple of seconds. In fact, we can actually collect another. By the way, these tools, if you're running on your desktop, then you use a Java Mission Control. But if you're running on a server or Kubernetes, you can actually use the shell and there's use JCMD command to actually create this kind of recording, and you can download that file into your system to analyze it later. Obviously, if I do all that in real life, I wouldn't have enough time. But that's something you can do. You can go and look it up, and there are instructions for you to say if I want to collect from the beginning or whether I want to collect in the middle of the execution. You can do that for the production application. Okay. So now let's see how long it takes. Remember, before that it's 1 minute. Now it's take 49 seconds. And I'm not going to. I don't think I have time to show you all the reason. But what happened is that inside the JVM, this line dot split is actually have an optimization. If you only have one regular expression, it's not a full regular expression matching certain things. If you just matching one character, it will basically do what you would do using a char add, right? So that's why it's reduced the time from 1 minute to about 49 seconds. And obviously, if you're actually doing the char add by yourself, you would actually find that it's actually much, much, much faster. Okay, and I don't have time to collect the profile, but if you collect the profile, you will see that this line will be completely gone if you actually, well, let's try that. Let's collect the flight recorder, and let's do 30 seconds as well. Remember, you have to be comparable if you're collecting this profile. So collect the same amount of time. Otherwise, it will be not comparable, right? But if we do the same thing for half a second. Okay. Oh, it finishes before. This is why it's give you an error, because it finished before the profile. But you see, it takes actually slightly less if we actually replace it with chart ourselves. So that's an example of how you would actually use these tools to analyze your performance issues. So obviously, it's a very simple one, but this tool is really good at also doing complex application. It runs in the background, very low overhead, so it's a good tool to collect this information. All right. So the other tools that I want to talk about, I'm just going to touch it quickly. This is also really good for production issues and things like that I've used. It's called the async profiler. I'm afraid this is Linux only, so for those of you who use Mac, I'm sorry. Because it uses the kernel's, Linux kernel's perf profile subsystem, and it's very low overhead. A lot of my colleagues actually use it in production, and it's collect some really good results. So I highly recommend that you use it, try it out for your Linux servers. And I'm not going to talk about those. I think I'm going to give you 3 key takeaways before I go. So measuring performance allows you to make sense of what's going on in your system, your throughput and latency. Remember, fast means a lot of things. It's quite overloaded. Make sure you know what fast means from your boss. Is it latency, how fast response, or how many stuff you can process? Make sure you know exactly what your boss actually wants. A good benchmark is an important tool to help you fix production issue before production. And if the takeaway from the talk is beware of what you're measuring, beware how you're measuring. Otherwise, you'll run into that JIT chart with multiplication that I'll show you, right? So make sure that you do it right. The third thing is there are many Java performance measuring tools, and use them wisely. So I told you about all the profiling and the sampling profiler and how that would affect the data that you collect. So those are the 3 key takeaways. If you fall asleep for the last 40 minutes, those are the 3 things that you should take away from this talk. Okay? So I'm nearly out of time. I've got 2 minutes, so I will open it to anybody who have questions.
请问有人需要发问的吗？
And by the way, that's my LinkedIn profile. If you want to contact me for whatever reason, then yeah. So.
Okay, it seems nobody has some questions. Okay, you have a question. Okay.
You have mentioned some tool about if our application is running on the server and
Right.
or KBIS. Can you say again which tool we can use?
So the Java Mission Control I'll show you, you can actually launch it from the command line. You can use, in the JVM, there's a tool called JCMD. If you look it up, JCMD command. Yeah, and you can actually kick off the JVM to, so let's say Kubernetes, you can create a shell, and you can run JCMD against that process, and it will collect this Java flight recorder recording for you, and then you can download that binary file into your system, and you can use exactly JMC tools that I'll just show you to look at the profile. And that's been proven very, very useful in production. And I presume everybody using Java 8 here, but because anything before Java 8 is not available, but I presume everybody is using Java 8 here, right? Okay.
Okay, thank you.
And the async profiler, I haven't got time to demo, but that's also able to run under Linux command line. So I presume your cloud is Linux-based, and you should be able to use the async profiler for that as well. That collects slightly different information, slightly different way from JFR, but it will also give you the same information. And I mentioned that in my slide, so you can take a look at that.
还有人有其他问题吗？Okay, let's give a big round of applause for Sunny's excellent presentation.
Thank you.
Thank you for sharing your insights and expertise on Java performance tuning.